Hey everybody, I wanted to do a part 2 to my video about prop pitches because there's a lot of confusion out there. Now look, I need to give you a warning. I am not saying I'm 100% right. I'm only giving you the data from my testing. Okay, just my data. So there is a misconception on the way that the torque of an electric motor works and the way the torque of a gas engine works. Okay? So what I really want everybody to think about for a minute is that where do you get that oomph, that power to turn the propeller? On a gas engine, it depends on the displacement and the RPM, the carburetor size, how well the engine breathes, how well the exhaust work, if it's a tune pipe. There's all these variables, but let's just hypothetically say that we know that there is a gas engine that is powerful enough to turn a propeller, let's say 5,500 RPM with a 3010 pitch prop. And that's the engine hitting its peak horsepower at that RPM, hypothetically. So if you put a bigger pitch on and you start to pull that motor down on a gas motor, there is no way to increase that horsepower unless you go to a bigger carburetor or a different exhaust. You have to increase the horsepower. Electric motors have a maximum watt that we don't want to exceed on the motor or we'll get it hot and melt the wiring. Okay? Our electronic speed control has a maximum before we can blow it up. So this is where it gets a little confusing for some people. And I'm going to talk about prop diameter because I didn't talk about prop diameter last time. But I want to show you some numbers. These are real numbers from my testing. I took a 3010 propeller. I was able to turn it at 5,500 RPM. I had a prop pitch speed of 52 miles an hour, which is a little bit slow. I was pulling 135 amps. Okay? I believe this was all 10S. I think this was 10S. Then I turned a 3012, pulled my RPM down, you'll see here, to 5,300. My prop speed was 62 mile an hour. I was pulling 148 amps. Okay, so if you see there, I'm increasing my amps because I'm pulling that motor down. That motor is loading up. And as long as my speed controller can hold that 148 amps and whatever the watts were, 5,600 watts or whatever it was, my system's working good. I went to a 3014, pulled my motor down to 5,100 RPM. My prop pitch speed is 72 mile an hour. I'm getting much better for a cruise speed if I pull the RPM back. My amps went up to 159. Now, some people think on electric motors, if you go to a lower pitch, you get more thrust. My testing does not show that at all, unless you increase your cell count. So let's think about that for a minute. If I've got a low pitch prop and I'm turning 5,500 RPM and I know I can put 160 amps. This is only 135 amps at 5,500 RPM. So let's say I increase my amps. My RPM is going to go up to like 6,200 or 6,400 RPM. Is that good? No, it's not. Your pitch speed has just gone way up. So are you really creating more thrust? Yeah, but is it because of the lower pitch? No, you're turning more RPM. What happens when you turn more RPM? You have more drag on the propeller because drag is squared. You don't want more RPM because it's got to push that propeller through the air faster. Okay? So what do? If I want to increase the amps of this 160 without turning that propeller much faster, but I want to have more thrust, I would go to a 32 or a 34 diameter prop. I've tested that. I've taken a 3410. No, it was a 3210. Took a 3210. Guess where my RPM was? It dropped. But I went to 12S. Brought my RPM right back up to 5200 RPM. My prop speed didn't change. It's the same pitch. But I had a bigger disc pulling more air. My thrust went up. So when people take an electric motor and don't change anything and just put a lower pitch prop, you're not producing really any more thrust. The propeller will spin faster because there's less drag because you have a less pitch on it. But until you increase your amps or your cell count, you're really not adding any horsepower to that airplane. So really guys, if you go out there and test this, you'll see what I'm talking about. So when I tested all of this with a 30, and my propeller was a, oh shit, I don't remember. I don't remember what prop it was. Prop design is a really big thing too. I tested Zinger props, which they're out of business now, but they were gas props made for really a lot of vibration, shaking. And the problem with big, thick airfoils is electrics, it's just not that efficient. Gas motors produced a certain horsepower at a certain RPM, and nobody really cared how efficient those props were. So let's just say for a minute, I had a 32, 10, a 32, 12, and a 32, 14. What would these numbers look like? If I didn't change anything here, these RPMs will come down. So that 3210 would, I'm trying to remember my testing, I think it came down about 400 RPM. So let's say it came down to 5100 RPM. The bigger diameter prop, right everybody? This I know was in the high 4000s. No, I didn't have a 12, I had a 14. This was 4600 RPM. Okay, what's happening to my prop speed there? They are dropping ginormously. Okay, so let's think about this. So if I have a 10 pitch prop that is turning 5100 RPM, I have a prop speed of, prop speed of 48 miles an hour. How do I get that up? I'm going to increase my cell count. I want to take that 135 amps up to about, up to 160 if I want to. So in theory, I could put probably a 34, make this a 34 diameter prop. Okay? I'm going to have all kinds of thrust there because I'm going to keep my prop speed up, but I'm increasing the disc size. It's grabbing more air. So the thing is everybody, I know this goes against what everybody used to do with gas motors, but keep in mind a gas motor, you could not get more out of that motor unless you went to a different nitro or whatever. So the gas motor came up and let's say peaked right here and then dropped off its power curve. Electrics are linear, but guess what's about electric that's neat is if this is 10S, you can bring your power up here with 12S. You can't do that with a gas motor. So what did we do? We lowered the pitch and went to a larger diameter. That gave us more thrust. So on electrics, lowering your pitch does not necessarily mean you're going to get more thrust. It means you're creating a more inefficient system on your airplane. From my testing, I know I'm going to get people that tell me I'm full of crap here. I don't care. My testing works on my airplanes. My testing on the bench tells me this is right. And think about it. Of course it's right. If you're going to lower the pitch on a prop, the engine's going to turn more RPM. More RPM is bad. Okay? What's important is what is your pitch speed? You got to have enough pitch speed to fly the airplane through the air. So if you've got only 135 amps, think about the maximum power you pull on your motor. In your system. You got to think about what's my maximum watts and what's my maximum amps for my speed controller. If I've got 160 amp speed controller and I'm only hitting 135 amps there, I'm using a 30-10, but I want the 10 because at 5,500 RPM, that 52 mile per hour is perfect to fly my big Cub, let's say. But boy, the Cub just doesn't feel like it's got any power. I don't want to go any faster. I'm going to put a big old honking, probably 34-inch prop here. I'm sorry. Keep the pitch at 10. I'm going to put a 34-inch prop on this. Okay, added 2 inches, and my amps will go up to probably 145 or 100 and let's say 50. It's going to shorten my flight time because I'm pulling more amps. Okay, but the thing is I can increase my cell count too. So you got to play around with this. Okay, every time you go down in pitch, it's less load on your motor, and your amps are going to drop. You add cells then. Okay, keep in mind another thing is understand your pitch speed. So here's something. Whoops. Here's something I wasn't sure I was going to dive into, but I think I'm going to do it. If you think your plane's going to fly, let's say 50 miles an hour at cruise speed, you want to figure out how to get a pitch speed that is going to be around 62 to 63 mile an hour at cruise. So that means you may at full power at maximum RPM have a pitch speed of 85 miles an hour. You want to be able to throttle back. So try to think about this for a minute. If I have a prop disc of a given size and a pitch of a given size, that is going to give me a certain amps, right? So if I want to increase the thrust, I will most likely go a bigger diameter prop and go down in pitch. I may go up in cells to keep the RPM at that sweet spot. So let's say the max power here, max power pitch speed is, I'm just going to use a round up a number. Let's say it's 90. And we know 60 is that cruise speed where we can fly at, let's say, 45 miles an hour. So 90's, that pitch speed is 90. So what happens if we lower the pitch? The motor turns faster. Now that 90 turns into 100. Well, 100 is too fast. Add diameter to the prop. It'll pull the RPM back down. Okay? So think about that again. So what happens if we know that 90 is that speed we want? And you take your calculator and you look and you say, okay, I'm turning and I'm making this, well, I could do it right. Hang on a minute. Let's find a pitch speed of 90. So if I've got a 10 pitch and let's say it's turning, it's going to be a lot of RPM. Let's say it's turning 7,000 RPM. Let's see what that gives us. Okay, what I'm going to do then is I'm going to go up in pitch. Let's say it's a 14 pitch. 7,000 RPM. There we go. We got 92. So a 14 pitch at 7,000. So a 14 pitch at 7,000 RPM is 92 mile an hour pitch speed. Okay? So what happens if I say that 92 is too fast? Okay? I could say, okay, I only want 80. And 92 is fast unless you got a fighter, a warbird, or something you're wanting to break a record with. So, and I'm talking about RPMs on large diameter props. Smaller props, everybody runs it at 8 or 9,000 RPM or 10,000 RPM. I'm talking about my big motors, my 150 to 200 kV motors. So let's say we want to go down to 80 at full power. So how would we do that? If we drop the pitch speed, that motor is going to turn faster, right? We need to add diameter to the prop. Okay? So if at 14 pitch at 7,000 is 92 mile an hour pitch speed, and we went down to a 12, that lowers it 79. So now we're at 79 at 12. Okay, so what's going to happen here? The 12 pitch is going to pull less load on your motor, so your RPMs may actually go up to 8,000. So now you got to go, uh-oh, what happens at 12 if I'm at 8,000? I'm back to 90 again. So guess what happened, everybody? My pitch speed didn't change much because the RPM went up. Now, the RPM wouldn't go up 8,000. I'm exaggerating it. But the RPM would probably go up 400 or 500 RPM. So that would probably give you somewhere in the high 80s. But if you want more thrust, you go to a larger diameter. Okay? All you got to do, everybody, is understand what do you want that target speed to be of your airplane. And if you want that cruising, most of my planes cruise at 35 to 40 mile an hour. So at full throttle, level flight at 50 some miles an hour, I normally want a pitch speed of 14 because I'm in the 5,000 or 4,900 RPM range. Okay, so what I'm really trying to say here is when you lower that pitch, you're unloading your motor. The amps will go down. And I'm probably going to, at the end of this summer, do a full video where I test all this with my 150 and my 220 kV motors so you can see what the data looks like off my speed controller with the amps that are being drawn. But you've got to really keep in mind, everybody, that there is just a lot of stuff you've got to do and do it yourself and do your own testing and look at your results to understand how this works. But lowering your pitch does not necessarily give you more thrust. The motor will just turn faster and actually you get a faster prop speed. Now, does that faster prop speed move more air? Yes, but are you really getting raw thrust? You're not. When I put it on a bench, everybody, I'm telling you, when I put this on my bench and I had my scale set up, if you remember last year I built the rig with the swinging arms with the motor on it, and it has a digital scale hooked up to it. So what happens when I lower the pitch, the motor just spins faster. It doesn't produce more thrust. You're not seeing more thrust on that motor because the load of the motor goes down. So think about that, everybody. If the load on the motor, if this is the amps, and just let's say because it's linear, it's electric, this is my 160 watts. When I lower pitch, you're coming down to 150 watts. Okay, is the RPM going up? Yes, the pitch speed's going faster. But on the scale that's pulling that motor, you're not increasing thrust. The motor is just spinning faster and actually is less efficient that way. So if you want to increase thrust, you increase your diameter of your prop. Okay, or if you've got a warbird and you've got a certain diameter that has to be there for scale and you want more thrust, you're going to add more watts to the system. You're just going to make the prop spin faster. But what I'm saying here is if you're just wanting to take a 30-inch prop that's a 14 pitch and go down to 10 and think you're going to get more thrust, you technically don't, unless you go to a larger diameter prop. So I hope this makes sense for everybody. I know some people are probably going to find something that says this is wrong. This is my test data that I did myself. I'm kidding you not. This is test data that, well, you've seen my test data. So just go back and watch some of the other videos when I was testing the C-130 setup. But I hope this helps everybody understand. The biggest reason you want for me, when I design an airplane, I want to design it for the largest propeller I can put on it. For scale, some of my big airplanes actually needs about a 40-inch prop. And I don't have a system efficient enough to turn a 40-inch prop right now. You know, I need about 10,000 watts to do that. And, well, I've got the motor for it. I just haven't bought the speed controller. It's a 300 amp speed controller, and it's about $800. So, I hope this helps everybody understand this. I know I talked about a lot of stuff, and if I confuse you, I apologize. But to recap this, if you have a 10 pitch, 12 pitch, 14 pitch, and I know you can get up to 16 pitches, but not in the large diameters I'm using. I wish you could. I just wrote a 12, didn't I? So we got a 10 pitch, 12 pitch, 14 pitch. If these were all the same cell count, the only thing that's going to change here is RPM. Okay, the 16 is going to be a lower RPM. Well, let's just make up something here. Let's say that's 4,500 RPM. The 14 pitch might be 5,000 RPM. The 12 pitch might be 5,500 RPM. And let's say the 10 pitch is 6,000 RPM. Your prop speed goes up because, or I'm sorry, the prop pitch speed stays almost the same because your RPMs are going up when you do this. Okay? If this 16 pitch at 45 is a given pitch and this 10 at 6,000 is a given pitch, this is turning a lot faster because it's a lower pitch. You want to, and your load on your motor goes way down. You may see 160 amps here, and here you might only be seeing 140 amps. If you want thrust, increase the diameter of that disc because you're going to be grabbing more air. So I hope that makes sense to everybody. And there are people that swear, and they're wrong. I know a guy that was flying an extra, and he put a really low pitch electric prop on it, and he flew it and said, my God, look how vertical it goes, and look at how I can hang it, and how I can do all this stuff. And, you know, when we put it on a watt meter, it went down 15% the load he had on that motor. The motor was spinning a lot more RPM, so the prop pitch speed was still staying pretty much the same. But was he truly getting more thrust? If you put it on a scale on the ground, he's not. You got to add diameter to it. So I hope, look people, sometimes I see things in my head from my testing that I know and I don't know how to completely explain it sometimes. But I hope I did a good job so you all understand that. Because this is a real sticking point for me, because I got an email from a guy after I did my prop pitch thing, and he says, you know, Damon, you really didn't cover how much more thrust you get by lowering your pitch. And once I explained all this to him on the phone, he goes, you know, that makes total sense. I get it now. So he actually added 2 inches to it. He went from like a 14 pitch down to a 10 pitch, but increased to 2 inches on the prop diameter. And he says his plane is hovering at like 35% power now. Now, it doesn't go fast at all. If everybody remember those yard darts or whatever those things were we flew 20 years ago that would just flutter if you went more than 20 mile an hour. But hope this helps everybody. I know I'm going to create a shitstorm with this video. I don't care. I just know what my testing does. And I know electric is voodoo witchcraft compared to gas engines. And I hope this helps you all. I really do. So thanks for watching my videos, everybody. Have an awesome day.